right, this is 7.4 notes, approximating square roots. And we are going to talk about a couple vocab words to start off. So a rational number is a number that can be written as the ratio of two integers. Okay, so basically rational numbers are, could be 2 over 1, which is 2, or 1/4, something like that. Okay, or it could also be a negative number. So negative 2 over, I don't know, 7 is also a rational number. On the opposite side of that, an irrational number cannot be written as the ratio of two integers. So an example is the square root of any whole number that is not a perfect square. So example 22 is not a perfect square. So the square root of 22 is 4.69, and then it goes on and on and on and on forever. Okay, that can't be written as a fraction because it's a decimal that keeps going on forever. And then the decimal form of an irrational number neither terminates or repeats. And I skipped one, the cube root of any integer, and I just dropped my pen. The cube root of any integer, so let's say the cube root of 12 is approximately 2.28. It goes on forever, so this cannot be written as a fraction either. All right, so our key ideas. This is the number system as a whole. So every number is a number, obviously. Okay, and then we have real numbers and imaginary numbers. Okay, imaginary numbers you are not going to worry about in middle school. This is a Algebra 2 concept, a pre-calculus concept, and we are not going to worry about it in here. But we are going to worry about real numbers. Okay, and then real numbers can be split into two categories. The irrational numbers, which is the numbers that cannot be written as the ratio of two integers, and then real numbers that can. So we have natural numbers, which I like to think of as you can count on your hands and your toes. Whole numbers, the only addition is you add 0. So integers is a set of whole numbers, which is 0, 1, 2, 3, and their opposites, which is negatives. And then rationals, you can have decimals and fractions. Okay, so we're going to have to classify some numbers here in a second. I'm going to give you a number, and you got to tell me what type of number it is. Okay, so here's some examples. I'm going to do A, B, C, and D with you, and you are going to do E, F, G, and H on your own. Okay, so square root of 12, and I just happened to do that one. The square root of 12 is 3.46. Actually, I did the cube root of 12, so this is different. So this is 3.46410, on and on and on forever. Okay, so this is an irrational number. All right, looking at part B, we have negative 0.25. Now, if you look back, this is a repeating decimal with the 0.25 repeating. So if we look back at this definition, the decimal form of an irrational number neither terminates nor repeats. Okay, so this can be kind of tricky. Since it can't repeat, we know that this is not an irrational number. It is actually rational. Okay, that is, ooh, what happened to my blue? That's a tricky one, but this would be a rational number. Okay, C is the opposite of the square root of 9, which is negative 3. If I look back at my chart, negative 3 is an integer. Okay, it can't be whole or natural, so this is just an integer. Okay, 72 over 4, if I simplify that, I get 18. So if I look back, I can count 18 are my natural numbers, and it is also whole, because it could include 0. It is also an integer, right, and it's also rational, okay, because it can be written as a fraction. So this would be all 4. Let me get back to this. So this is natural and whole, integer, that's the bell, and rational. Okay, go ahead and try E, F, G, and H on your own. Okay, and pause it, and I'm going to write out the answers so you don't have to watch me write words, and you can check your work. All right, press play, or press pause. All right, pi, if you put it in your calculator, it's 3.14159 and so on, so this would be an irrational number because the decimal never repeats. F is also irrational because although it kind of looks like this decimal may repeat, it's 1, 2, then 1, 2, 2, then 1, 2, 2, 2. Okay, so this is not a repeating decimal, which makes it irrational. The opposite of the square root of 196 is negative 14, so this is an integer. It's also rational because it can be written as a fraction. It could be negative 14 over 1. And then the last one, the cube root of 2 is not a pretty number. It's 1.259921005, and so on, so this would be irrational. Okay, looking at example 2, now we are approximating square roots, okay, and what it means to approximate is to kind of guess, to get pretty close. Okay, so we're going to do two things. We're going to guess to the nearest integer and to the nearest tenth. Okay, but we're going to make kind of an educated guess because we know that the square root of 71, we have some perfect squares that we are familiar with. Like the square root is, or 7 squared is 49, 8 squared is 64, 9 squared is 81. Okay, so we can kind of get close to that knowing that. So what we're going to do is make a table of values. This is going to be x and x squared. And I know it's kind of close in the 7, 8, and 9 range. So that's what I'm going to try. I'm going to do 7, 8, and 9. 7 squared is 49, 8 squared is 64, 9 squared is 81. Okay, but I'm looking for the square root of 71. So I know it's somewhere, it's going to be somewhere between 8 and 9. Okay, and then I'm going to ask myself, well, is it going to be closer to 8 or is it going to be closer to 9? And 71 is 10 away from 81, and it's not that far away from 61. So I'm going to say to the nearest integer, part A, the square root of 71 is approximately, I'm going to use a curved equal sign, is approximately 8. Okay, but the second part of this question is you have to estimate it to the nearest tenth. This is part B. Okay, so I know that it's closer to 8, but it's kind of sort of in the middle. So I'm going to try 8.3, 8.4, 8.5, and see where that takes me. Okay, 8.3 squared is 68.89. 8.4 squared is 70.56. We're getting closer. 8.5 squared is 72.25. Now we got too much. Okay, so we look for what's closest. And to the nearest tenth, the square root of 71 is approximately 8.4. Same thing for part B, except for I just did that up here. So, my bad. That's part B right up here. This should be, this table estimating to the nearest tenth should be the second part. Okay? Alright, these are the 4 on your own. Now, these take a little bit, so I'm going to pause and write them all out. But keep in mind, you're making 2 tables for each. Okay, so for this first one, the square root of 8, I'm going to think to myself, okay, what is that kind of close to? And I know it's going to be 2 squared is 4. 4 squared is, oh, excuse me, I skipped 3. That's what I did. 3 squared is 9. 4 squared is 16. Okay, so that's how I would set it up. And then once you know the tenths, you set up another table and kind of gauge by what number it was up here. So pause these, try them, hit play when you're ready. All right, I apologize. This is a lot of writing and a lot of calculations, and it just takes a while, so I apologize. But I'm going to try to talk you through, at least talk you through A and B. Right, so square root of A I know is going to be somewhere between 2, 3, and 4 because 2 squared is 4, 3 squared is 9, 4 squared is 16. Okay, but then I know that 9's pretty close, and it's a little less than that, so then when I try the tenths place, I try 2.7, 2.8, and 2.9, and then I look to where it's going to be closest. Okay, so 7.84 is closest to 8, which is why I approximated the square root of 8 to be approximately 2.8. C, ignore this opposite side till the very end, okay? It's really, don't let it trip you up, okay? So 4, 5, and 6, 4 squared 16, 5 squared 25, 6 squared is 36, okay? And it's closest to 5, which is really the opposite of 5, which is negative 5, okay? So I know it's a tiny bit less than that, so I try 4.7, 4.8, and 4.9, and 4.9 ends up being the closest at 24.01. So I would approximate the opposite of square root of 24 to be negative 4.9. Check my work on B and D and see if you got the same thing, and if not, bring questions tomorrow. All right, last part of this section is comparing real numbers and estimating which one is greater. Great thing about this is you can use your calculator, okay? So the square root of 5 all I'm doing is plugging in and getting approximately 2.24 if I round to the nearest hundredth. And 2 2/3, if I change this to an improper, is 3 times 2, which is 6, plus 2 is 8, so it's really 8/3. If I put that in my calculator, I get 2.66, repeating. Okay, so which one's greater? 2 2/3. These are easy. Okay. Example 4, approximating the value of an expression. So the radius of a circle with area A is approximately the square root of A over 3. Now this seems trickier than it is, but all it's really saying is the area of the circular mouse pad is 51 inches. So you substitute A is equal to 51. So if I have the square root of A over 3, I'm now going to have the square root of 51 over 3, which is, if I divide 51 by 3, is equal to the square root of 17. And now it wants me to estimate that to the nearest integer. So if I think about my x and x squared table, the numbers that are pretty close to that are 3 and 4 and 5. 3 squared is 9, 4 squared is 16, 5 squared is 25. So the square root of 17 is closest to 4, so my radius is going to be approximately 4 inches. Example 5, your real-life application. So the distance in nautical miles you can see with a periscope, which I guess is this thing that sticks out over water, is 1.17 times the square root of your height, where h is the height of the periscope above the water. Can you see twice as far with the periscope that is 6 feet above the water than a periscope that is 3 feet? Okay, so right away we're going to break this into 3 feet and 6 feet. Okay, so this would just be 1.17 times the square root of 3. That would right. And 1.17 times the square root of 6. Okay, if I use a calculator, I'm getting approximately 2.03 here. And if I use a calculator, I'm getting approximately 2.87. Okay, so you can see, obviously you can see farther with the 6 feet, but they're asking if you can see twice as far. Okay, so twice as far as 2.03 would be 4.06, okay, because it would be double that distance. So to find out exactly how far, how many more times farther we can see, I'm going to take 2.87 and divide it by 2.03. Okay, and when you do that, sorry, I'm doing it on my calculator with you, you get 1.41 approximately. So that means you can approximately see 1.41 times farther with a 6 foot than a 3 foot. All right, on your own, pause these. When you finish, hit play. Basically, you're just saying which number is greater. So plug them into your calculator, and that's basically it. Try them and then hit play. So yes, these really are that simple. If you change forward 1/5 to 21 over 5, that's 4.2, but the square root of 23 is bigger than that. Number 2, square root of 10 is 3.16. That's obviously bigger than the opposite of the square root of 5. That's going to give you a negative number. And number 3, the opposite of the square root of 2 is negative 1.41. And, oh my goodness, I messed up. Negative 1.41 is greater than negative 2, because if this is your number line and this is 0 and we have 1 and we have 2, negative 1 and negative 2, negative 1.41 is here versus negative 2 is there. So the opposite of the square root of 2 would be bigger. All right, that's all. I'll see you tomorrow.